Alright, Logic fans, welcome to our second video on section 2.2 of the text. Still going over semantic properties. I want to give you an example before moving on to other things of a slightly more difficult sentence. So let's go ahead and try this one as an example of a logically false or logically contingent, sentence, just so you can see it. Is this sentence logically false? Yes or no? If it is, prove it. Pause now. Alright, here's your hint. So remember, even though C appears twice here, we only count it once because we're counting propositional constant types. And so we're going to have 4 possible assignments to consider. 2 squared is 4, so we've got our 4. Fill it in from here if you can. Pause now. Okay, hopefully you've had a chance to pause, but we're going to go through this together, okay? So we're going to build our truth table in the standard way, all right? And notice that here we've got A implies C. So this column, arrow this column. So this is the antecedent, all right? So we got true arrow true is true. False arrow true is true. True arrow false is false. False arrow false is true, okay? So that's what that column looks like. Then what we're going to do is we're going to take the negation of this column. So this column goes true, true, false, true. So this column's going to go false, false, true, false. It's just going to do the opposite, right? Okay. Then what we're going to do is we're going to look at our conjunction truth table, and we're going to conjoin, let's say, this column with this column. So true and false is going to be false. True and false is going to be false. And then these are falses, right? So this is going to be false. False. And look at that. This is a contradiction. Okay? This is indeed a contradiction. This is a logically false sentence, and it satisfies our definition. Okay? So these things can take different forms. You got to be a little bit careful. And on the note of being careful, let me throw a little bit of a curveball at you. So in the previous examples, I've been sort of saying, here's one that's logically true, or a tautology. Here's one that's logically false. Can you prove it? Let me throw a sentence at you, not telling you if it's logically false, logically contingent, or logically true, and you have to discover for yourself from scratch, okay? So here's an example for you. I'm not going to tell you whether it's logically true, logically false, or logically contingent. It's your job to figure out which one it is and to prove it, okay? So F implies not F, all right? If F, then not F. Is that a contradiction? Is that a tautology? Is it contingent? What is it? And prove it. Pause now. Alright, this one might surprise you. That's the point, okay? It's a little bit of a trick. So if you haven't taken the time to actually work out the truth table on this one, actually work it out from here, okay? There's only one propositional constant type, therefore 2 to the 1 equals 2 logically possible assignments for this sentence. Try it now. Alright, let's rip through it together, okay? So obviously F can either be true or false under bivalence. That exhausts all possible assignments. In the circumstance where F is true, not F is obviously false, and when F is false, not F is true. Okay, easy peasy. Now we're doing this column, arrow, this column. True arrow false is false. False arrow true is true. This is logically contingent. This is not a contradiction, okay? It looks for all the world like it might be, but this is actually satisfying the definition of logically contingent, okay? So sometimes these things can surprise you beyond the alert for things like that, and be sure to run your truth table for 100% accuracy. Okay, I want to close by introducing a slightly more general concept, which you've undoubtedly already begun to sort of think about a little bit, but let's actually do it out, okay? So let's start with the reminder that the categories logically true, logically false, and logical contradiction, right? These 3 semantic properties of propositions are mutually exclusive and mutually exhaustive, right? So every proposition, pick a proposition from a hat. It's guaranteed to fall into one and only one of those 3 categories, okay? It will fall into one, it won't fall into none, and it won't fall into 2. It'll fall into exactly one of those 3. All right, so if you show that a sentence, for example, this one is logically contingent, which it is, then you know for a fact that it's neither a tautology nor a contradiction. It's neither logically true nor logically false. Okay? All right. Something kind of interesting here can occur. Let me throw a couple propositions at you here. Okay, here's 3 propositions I just pulled out of a hat at random. Okay? Slapped them down in front of you. There they are. Take a second and tell me if you notice anything that all 3 of them have in common. It might be a little subtle, but take a second and pause now and see if you can't figure out what fundamental feature these 3 propositions have in common. Okay, hopefully you've had a chance to pause and think about this. Here's what I was pressing for, right? It was a little bit vague, but they are all of the form P or not P. Okay, this one is clearly of the form P or not P. It's a substitution instance of this form, right, where D is P. This one is also a substitution instance of this form, okay, right, where P is just F or not G. And notice you got not P here. Same thing here, okay? Same thing with sentence 3 here, or proposition 3. This whole thing is P, and then this whole thing here is of the form not P, right? So they are all of the form P or not P. Now, another question for you. P or not P, if we run that through a truth table, and, you know, forms aren't true or false, propositions are true or false, but just playing along for a second, if we run P or not P through a truth table, will P or not P turn out to be a contradiction, logically false, logically contingent, or a tautology, logically true? Pause now. Okay, well, we did this one at the beginning of the other video. Well, we didn't do it in terms of P, but we did A or not A in 2.2a, video 2.2a, okay? And so it's going to end up being the same thing. So this turns out to be a tautology. Now, stay with me, all right? If you can follow a soap opera, you can follow this, all right? P or not P is a tautology, right? It's got a tautological form, shall we say, okay? Now, every one of these is a substitution instance of a tautological form, namely P or not P. Therefore, what follows about each of these 3? Pause now. Okay, great. So yeah, that's exactly right. All right, if this is a tautological form, and this tautological form, right, is a tautology, okay, and every single one of these is a substitution instance of this tautological form, okay, then every one of these is going to be a tautology. Every one of these is going to be logically true, okay, and indeed they are, and you could prove that by setting up a truth table for all of them, okay. And the big picture I want to leave you with is the exact same thing is the case if you have multiple sentences that are substitution instance of a contingent form, right? So something like P or Q is a contingent form, right? Okay. Then any sentence which is a substitution instance of this contingent form is going to be contingent itself. Okay. Similarly, for a logical falsehood, right? Anything of the form P or not P, or of any contradictory form, any form that's of a contradictory form, shall we say? Okay. Any substitution instance of such a form is itself going to be a contradiction as well. So this is a really nice thing. If you get multiple sentences and you can kind of see, oh wait, these are all substitution instances of some fundamental form, and I can see really quickly that that fundamental form is a tautology or is a contingent or is a contradiction, then I know that every single one of those sentences, I know which of the semantic properties it has. Okay? All right. Good work today, guys. Keep up the good work, and we'll catch you on the next video, 2.3, where we're going to keep building on these fundamental semantic properties of propositions.